Here I'm going to go through some trigonometry. So this is a Leaving Cert question from 2019. It's question 4, paper 2, and we're asked to show that cos of 2 theta is equal to 1 minus twice sine squared theta. So to use these, we're going to be looking at our formula in the tables. We can say that cos A plus B, I'll just write that out, that formula is equal to cos A times cos B minus sine A times sine B. And if we just replace that with theta, you've got cos theta plus theta equals cos theta times cos theta minus sine theta times sine theta. That's just cos squared theta minus sine squared theta. And from our basic identities, we know that this is cos 2 theta. We know that this here can just be replaced because we know that cos squared theta plus sine squared theta from our basic identity is equal to 1. If I rearrange that for cos squared theta, then cos squared theta is equal to 1 minus sine squared theta. So I can just replace that with 1 minus sine squared theta. So that's just equal to 1 minus twice sine squared theta, which is what we've been asked to prove. In the next question, find the cosine of the acute angle between two diagonals of a cube. It's a cube, so we know that all the sides then are the same. So let's give that an identity. We'll call that x. We know that all those sides there, the length, the width, and the height are all x. We know that our angle involves the internal diagonal there. But right now I can't find that internal diagonal with respect to x. So what I'm going to do is I'm going to look and see how can I access that internal diagonal. Well, if I can find what that external diagonal is with respect to x, which is that green line, we know that that squared is, because this is a right angle, we know that that squared is equal to x squared plus x squared. Okay, so that's going to be equal to the square root of x squared plus x squared, which is root 2x squared. So that's equal to root 2 times x. Okay, root 2x. Okay, now what I might need to do is try and find that internal diagonal. And here I know that that is x, because it's a cube and we've identified it as x. So that orange line, that internal diagonal squared, will be equal to the sum of the other two squares. So the internal diagonal is equal to the root of root 2x, ought to be squared, plus x squared. So we've got that's equal to 2x squared plus x squared, so that's 3x squared. So we've got root 3x. That's our internal diagonal in orange there. It's just root 3x. So quite often when we're looking at trying to find an angle and we know the size of a triangle, then we can use the cosine rule. So I'm going to look at, let's just highlight this triangle here. It's the same angle in blue. The internal diagonal I said was root 3x. And that's root 3x. But because that's half of it, it's root 3x over 2. And that's root 3x over 2. So using the cosine rule then, the opposite, and we want this angle, which is the same as the one in black. The opposite angle, okay, and we'll call the angle A. Okay, the side opposite the angle, which is x squared, is equal to the sum of the other two sides squared, so that's root 3 over 2 x squared plus the other side, which is the same, root 3 over 2 x squared, minus twice the multiplied by each other, root 3 x over 2 times root 3 x over 2 times cos of the angle A. And we need to just rearrange that for A. So therefore, cos A is equal to bringing this over the other side and bringing x squared over, it's going to be root 3 over 2 x squared plus root 3 over 2 x squared minus x squared, because we've brought, likewise I'm bringing this over to that side and I'm bringing that section over there and dividing. So I'm going to divide by that all over twice root 3 x over 2 times root 3, and we can just expand out our brackets there just to see. You've got root 3 x squared over 2 is 3 over 4 x squared plus 3 over 4 x squared minus x squared, all divided by root 3 by root 3, which is 3 x by x, which is x squared over 2. Cos of A is equal to 1/3. And you're asked to find the cosine of the acute angle. So the cosine of the angle is 1/3.